Hi, I'm Mr. Huber and I'm going to talk about exercise 11b. 11b. So we're given A to B is like 3 to 2. That's a ratio. And our second piece of information is A is 15 units of area. So we have a right-angled triangle, and that would probably more or less look somewhat like this. Let's do a better one. There we go. Like this, just a hand sketch. Here. A, B, and C. This is the side B, this is A, this is C. But we don't know the sides. So don't think that A is now 3 and B is 2. We only know the ratio of these two, okay? That's very important. But it's very useful too, because this is now beta, this is alpha. And we can work out alpha without knowing the actual length of A and B. Like this. Look, tangent alpha is opposite over adjacent. Opposite A over adjacent B. We don't know the actual length, but we know it's like 3 to 2. So tangent alpha is like 3 over 2. So alpha is arc tangent, the inverse function of tangent. So now we can work this out. Arctangent, shift arctangent, 3 divided by 2. Close the brackets, and we're going to get 56.31. Alpha is 56.31 degrees. Let's store this, shift store A. Why not? So this is stored as A. Now beta is obviously a piece of cake, because alpha plus beta is 90 degrees. So beta is just 90 degrees minus alpha. So beta in this case is going to be 33.69 degrees. Our problem now is we don't know the length of A and B, because we only know that in all the similar triangles that have this ratio in A and B, we know that these angles are always 56.31 and beta 33.69. But we do know something. We know that A, the area, is 15. So we could say, if we talk about all the triangles of this type, so we could say this is the length 3x and this is the length 2x. Why is that? Because we know A to B is like 3 to 2, or A to B is like 3 to 2. And that's the same thing as saying 3x to 2x, because you would lose the x. But it will be very helpful because we know, again, in a right triangle, like this is B, this is A, the area is A times B divided by 2. Base times height divided by 2, because it's half a rectangle. You know this is 15, and we just established that A is going to be 3x and B is 2x divided by 2. Okay, because the ratio has to be 3 to 2. It must be a multiple of that, okay? Because we're talking about similar triangles. We only know the ratio of A to B is like 3 to 2. So we can work this out now. This is 30 is 6x squared. So we can divide by 6, so that's 5 is x squared. And now x is plus minus the square root of 5. Obviously, in geometry, it must be the square root of 5. The square root of 5 is approximately 2.24. I'm not going to store that because whenever I use x, I'm going to use the square root of 5. Look how simple this is now, because now we know that a is 3 times x. It's 3 times the square root of 5, which is approximately 6.71 units of length. B is 2 times x, so 2 times the square root of 5, 2 times the square root of 5, that's approximately 4.47. And now it's easy to work out C, because look, you can use Pythagoras. C is in fact the square root of a squared plus b squared. So that's 3 square root of 5 squared plus 2 square root of 5 squared and the square root of it. So let's do this mentally. This is 9 times 5, so it will be 45. And this is 4 times 5, so it's 20. It's the square root of 65. So what's the square root of 65? Well, that's 8.06, approximately 8.06 units of length. Look, to give you a quick recap here, we were given a ratio, okay? And we were given an area as a second piece of information. With this piece of information, we were able to work out the angles. That's a good thing. But we were not able, with the ratio alone, we were not able to work out C, okay? So we had to say, we're talking about multiples here, okay? Larger triangles, because every triangle of this type, if I continued this line here, made a parallel line, I could draw many similar triangles, and they would all have the ratio A to B like 3 to 2. If this is 3 to 2, then this is 3 to 2, and then this is 3 to 2. The ratio is always the same thing. So we need to know what x is, because it must be somewhere in between. We don't know. Or somewhere on this line. And we were able to work it out by saying, well, if a to b is 3 to 2, then we could say this is 3 times x over 2 times x. And that was very useful here, because we could say, if this is 15, and that locks in our x value, okay? Because if you know 3x times 2x divided by 2 is 15, well, then you can determine x. So that's why this piece of information helped us to work out x. And once you know x, you know a and you know b. And then once you know a and b, you can work out c using Pythagoras. I know these exercises are quite a bit more difficult than the ones we did before. But well, we're always using the same thing. But thinking is required, that's for sure. So I hope it wasn't too difficult. See you in the next one.